Okay, it's all right. So in today's class, as we discussed that today we are going to talk about time series analysis and mostly how to do the visualization for time series data. And then my plan is in the next week, we will try to do two things. If one is how to do plot data on maps, on political maps or on the geo- geographical maps. And then also I'll start discussing next week, I'll start discussing how to frame an analytical dashboard. And uh, then eventually we will move to an area using how there is a package called Shiny app. It's mainly a R Studio product. Using a Shiny app, how can you build your dashboard? So that will be pretty much on the doing analysis using RG, R visualization using ggplot and all these things. And then we will move on to Tableau. So, and that will be the last component. Now, in terms of evaluation, so I'm going to assign one assignment today and eventually two more assignment. And the I have already assigned the semester project, which will have three component essentially. One component which you have to do a full visualization analysis of the data set as much as you can and present it using in RMD file. You create your analysis in the RMD file and create a PDF output of it, and then submit just the RMD file or the just submit the PDF file. That will be the first component, and evaluation will happen on that component. Second, you have to develop.
We use Jupyter Notebook.
No, RMD file.
Okay.
Um, or you can do Jupyter Notebook also. That's preferably in Colab. I would prefer Colab. In that case, you just do it in Colab. I'll give you the all possible thing that you can do. Either you can do it in RMD files and just give me the PDF, upload the PDF output. That is one possibility. Second possibility is you can do it in Colab and share the link with me so that I can just access your Colab notebook. So that will be the component one. And in that component one also, I will tell you what are the things I will look for and based on which I will evaluate. Second thing is, then second component will be on the same semester project. You have to build a analytics dashboard. Once you know how to build an analytics dashboard after that class. And then on the third component will be you use the same project, you analyze the same things using Tableau, so that essentially you're doing the same project but in three components, so that you get a full-blown development skill set. And I'll try to write down everything as by this. Today I'm going to assign the first assignment, and also I'll try to give you the first component or the first of the semester project that I will going to assign. All right, so let me share my desktop. Okay. So this is all right. Let me just hold on. Let me just Okay, can you see my desktop?
Yes.
Okay, so I'll share this R code, but instead of going through this, so I'll explain you each of these R code and all those things. So there is a data set that is available in R called air passenger data set. This is very popular data set, and you will see many, um, probably some, quite a few. I have seen YouTube videos where people have demonstrated time series analysis using these particular data set. This is one of the old and very popular data set. This is in fact known as classic Box and Jenkins airline data. Uh, the main reason I am I am using this data set is it is just sheer familiarity, and since it's a small data set, it will be much easy when you are learning something. You are learning it on the small data set. I've seen uh, comparatively learning is easier, and then once you get familiar with the time, like uh, how to handle time series data set, then you go on try more difficult, long, and complicated time series data set. um so let me so this particular line is for clearing the cache. So if you go to the environment, then you will see the environment is empty now. So it's, I don't know what it's why there, I don't know why it stopped. So let me just stop it, I think. All right. So yeah. So what happens is if you just say time air passengers, then it will give you all the times. So it's starting from 1949, and then February is 1949.083. So actually, if you look into the data set, is if you just say question mark str air passenger. So um, sorry, if you just structure, so it's a time series data. Now like in Python you have data frame or array or list. Similarly, time series is one class structure that is available in data structure that is available in R. It's called time series structure. Sometimes you define it as a TS, so time series object. Basically, if you take a array and you put it in that array as a TS, then and you give the start time and end time, and you give a frequency, like how within a one time unit how many observations you are seeing. If you give all these informations, then that new object in which your time series data um, is holding is typically called TS object or time series object. So it's like you can take a data frame and you can put it into a time series object. And in R, it gives you certain advantage because it automatically identifies, okay, this is a time series object. It will look for what is the time component. It will put the time component on the x-axis and put the y component in the y-axis, the value component on the y-axis, and plot the time series. So it's a air passenger already is in a time series object as a time series object. All right. Now what I have done purposefully, I have uh, converted into a data frame. Why I did that? And I didn't change the name of the data set. I give a different data, a name, I just give ARP underscore data. You can see I have given, I put it in a data frame. Now, basically, Jan is 1949.000 and February is marked as a 0.083 because I need a continuous time. So, which is basically 1 out of 12 kind of thing. I think if you just say, yeah, 0.083, then 2 out of 12 is 0.1667. So 167. So this is how Jan, February, March are being converted into a continuous time scale. And the number of air passengers, I think it was in 100,000s or millions. I think it was in 100,000. And then, all right. Then what I have done, that I have just first check how many sample points do I have. 144. Just a minute, guys. Sorry, guys. All right. Okay. So next, what I have done, I have just read how many data points that we have. Okay. In this line. So it gives me 144 data points. And then what I'm saying that, all right, I'll just take 70% of the data as in. All right. Now what I'm saying is, all right, you just take the basically first many, like from 1 to 101, the older data set as training data, and rest of the 102 to 104 as the test data. Acha, do you guys familiar with the concept of training data and testing data?
Yes.
Anybody have any doubt? I mean, who's not familiar or want me to discuss? Okay, okay, one of you are saying no. So let me explain you the concept of uh, training data and testing data. So, all right. Uh, so the idea of training data and testing data is basically what it is coming from machine learning, data mining, machine learning. This concept will be introduced more detail with in your data mining machine learning course in during second semester. But what I will do, I will just quickly tell you the uh, what that training data and testing data does. It's basically takes a data and split into two. One data is basically, I mean, typically it happens if you have a problem where you want to do a prediction or you want to do a forecasting. Suppose this is the problem that you are looking for. At that time, what we do, we take the main data set and then we split it into two, training and testing. Then what we do in the test training data, we train the algorithm or fit the model that we want to use to predict the value that we want to predict. Then once we trained that model or trained that algorithm, then we apply that trained algorithm or trained model on the test data set. Okay. And then we check the performance of the algorithm on the test data set. If And then similarly, we check the performance of the algorithm on the trained data set. If the performance of the algorithm in trained dataset and test dataset are somewhat similar, then you can say that you have a reasonably workable model which you can use in future, but or in the production. But if you oftentimes what happens is, if you are using very complicated model or something very complex kind of model, some oftentimes it happens that your performance in the trained data set is very well, but in the test data set is very poor. If that thing happens, you don't want to put that model in the production, or you don't want to use it, because that means the model can't perform well if it is an unknown data. So that means the algorithm or the fitted model is performing poorly if it is seeing an unknown data, but it performs very good if it's seeing a known data. Trained data is the one where the algorithm or the model are being trained. So that is the idea. Okay. Now, there are different ways of splitting trained data and test data. If you have a cross-sectional data, for example, like, typical survey data or something like that, then people do split in a random way, using simple random sample uh, without replacement. That is a typical case. But if you are not using simple random, but if you are typically seeing a time series data, then what happens? Then typically people prefer to split it on time scale. Older data are being used for the training the algorithm, or training the learning, for the learning, and newer data points are used for the testing, or testing how the uh, learning is being, or the algorithm being performed. So this is the idea of training and testing. Anybody have any doubt? Clear? Any question?
No, sir.
All right. Okay. So let me go back to my R code. Now here what I'm going to do is I'm going to so if you I have create a column where the first 101 observations are being marked as train. Let's see. And then from 102, the newer observations are marked as test. We will keep the newer observation for testing, and older observations for training. And then here we split the training and testing. So if you look into the training, we have all the observations as training observations, and these are the test, all the observations of the. So now I have split the data into train and test. Now this piece of code, what I'm doing is I'm just creating like same idea of layered architecture, and then put a grid there, and then I'm going to plot this is the original data set where I'm plotting the time on the x-axis and the values on the y-axis, and just and then plot the points and then join them with this line. And then, so the sky blue color part is of the data I'm going to keep for the training and or learning. And then this part I'm going to keep for the test. And this is the, basically this is the time point where I'm splitting the entire data into train and test, and majority of data I'm keeping for training, and the last 30%, newer 30% of the data I'm keeping for test. So now I'm going to plot the, so what I'm doing here, I'm just fitting a simple straight line. So here I'm just fitting a straight line. Basically I'm fitting, all right, air passenger value, whatever that, equal to A plus B times straight line I'm fitting. And so this is the model that I have fitted. The intercept is -54751, that is A, and B is 28.14. So I got the A and B value, and then AB line is, I'm just fitting a straight AB line like this. Then what I have done is I fit another mathematical model. So that I said, okay, now I'm going to fit a quadratic model. What is quadratic model? Of time, quadratic over time. So maybe that will be a better one. So A plus B times time plus C times time square. Okay. And what you can do, you can put a time plus I times square, and then rest of the thing will be exactly same as the previous one. If you do that, then you can fit a second model, which is a quadratic model. I named it as a fit 2. Now you can see this is my intercept A, this is my slope B, and this is the coefficient for the quadratic terms. And then
What does capital I mean?
so capital I is basically, if you want to put, so basically I want to, it's basically syntax. The syntax, what it does is, in my original data, there is no time square column, but time column is there. So if I want to add that as a time square as a new engineered feature, I can put it in I, and then whatever function I want to put there, it will just take it. Okay. So this part, I have to give it like this in this syntax. Does that answer your question? Okay. So now in this part, what I'm doing, I'm just predicting the model, the actual values, and then, so this is the actual origin, the focus that we are getting during on the test data set. And this is the, you can see the blue ones are the one which I'm getting from the, for the training model. So it's maybe quadratic is a decent model. Then what I have done, this is what I have taken 2 pi, and I have said that, okay, I'm going to add few more term in my model, like maybe AFP equal to A plus B time plus C time square. But now what I want to add a new thing to add. So maybe D1, it's a coefficient that I'm going to add, but sine of omega so omega times time. Okay, so I'm trying to add a sinusoidal kind of behavior, and plus maybe D2 is or E1. So D1 and E1 are also coefficients, sine of cos of omega times time. Okay. Now, remember that in my data set, it's only time. All I have is time as a feature. All I am trying to do here is, so these are called typically engineered. If time is a feature of the data, and that makes it a time series data, then these sine omega times is called engineered feature. Okay, or in that is typically in the machine learning literature, it is called engineered feature. And in the statistics literature, it is called transformed variable. Okay, so these sine cos transformations are known as engineered feature of engineered feature in ML literature, machine learning literature, in stat literature, in stat literature, it is transformed predictors. Okay, you will know more about it in detail when you will learn data mining machine learning. And in the third semester, you will have a course on predictive analytics with regression and classification. In that course, you will learn more about the statistical aspects of these things. So I'm just gently introducing you to this. Now you can see you have time and then some more predictors. Okay, and these predictors is basically engineered predictors. I'm just splitting the data. I have done it on the main data, and now I'm fitting that model. Then I'm doing this prediction. Now I'm going to plot the predictions. So I'm just clearing up here. And this is the trained data. As we know, it is the test data. This is the splitter. Now you can see this is the prediction of how the thing have predicted. Now it can take care of this sinusoidal behavior. And then this red curve is the predicted behavior. Let me just increase it the size. So you can see clearly that the blue curve fit the data very well, but at the time progress, it performance deteriorate, and it kind of definitely it able to predict the trend very well, and then some of the, at least the sinusoidal behavior is being picked up, but definitely it's uh, missing the very low and the very high. So we can do a lot of other stuff. So we can now, so there in the previous model, I added sine omega t and sine cos omega t. You can add more sinusoidal curve thing like sine 2 omega, cos 2 omega, those kind of things. So if you add those, what will happen? So now you're becoming more complex models. As you keep adding these functions, what will happen? You will keep adding more and more complex models. So I'm cleaning it up with this thing. And now you can see that as I added sine 2 omega, cos 2 omega, it did able to start mimicking the behavior of the data. So this is how typically a typical time series data being analyzed. So now if I pick up the third sine cos omega up to third order term, so let me just run the whole thing in one go. You can see that it is even doing better. Okay, but as you see that it's, and in the sixth model, and sixth model, what I have done, I have taken that log transformation. And why I did that log transformation, because if you look into the up and down, it's some sort of, some kind of exponential increasing is happening. So on the air passenger, I have taken a log transformation. And if you fit that log transformation model and did that prediction on the based on that, so you can now see the out of the sample prediction is almost picking out the top picks. I mean, it's missing almost nothing. Of course, train and test both are doing well. So this is how typically we do the time series analysis. But as I said that this is a toy data. So we cannot, I mean, it's a well understood toy data. So it's pretty much, you can do all these things, but, and well behaved data, you can, but there are a lot of other data sets which are very, very difficult to predict. In fact, this is one data where you can almost predict everything pretty well. And there are data you will not be able to predict anything. So in this is an example data set where you able to predict pretty much anything you want. Okay, it's your prediction ability almost 90% or 95%. I don't know. I have to check the actual accuracy. But if you check your accuracy, if you little bit, even you more tweak, if you put more tweak, you will see your thing, your ability to forecast these things gone up to very high, like 95, 96, 97%. And now I'm going to give you an example where your ability to prediction is almost zero. Okay, so let me go give you an example. So this is one kind of example that I gave you where you can predict anything you want. Big library quant mod. This is one library which essentially, and then in quant mod you have a function called get symbols. Okay, so what get symbols does, this function has, one of the feature of this function is it can download data from Yahoo download close prices of data like stock market data from Yahoo. Say, let me, if you go to say Google and check for Yahoo Finance India. Just if you give Yahoo Finance, it will take you to the US website. But if you give Yahoo Finance India, then they will take you to the Indian website. And then if you say, I'm looking for say TCS, TCS price. Okay. No, this gives me a different, this is a different company. US-based company, TCS, Tata Consultancy Services. Now in the Tata Consultancy Services in Yahoo is marked as TCS.NS. So this is the ticker. This is typically called ticker. So you give this value TCS.NS and source you have to give, I think it is default Yahoo, but we can just give Yahoo. And if you run this code, so looks, you will see, go to the environment. You see there is a function called data set is available from 2nd January 2007 till the latest, till I think 4th November 2021, which is the Diwali day. On Diwali day, there was a Muhurat trading during that time. That was the last time. So it will always give you the last trading close price day. So now it is open, the market is open, but that today's data will available only after when the market will close. So now if you just take TCS.NS and just say, take that just it close price and try to say plot. So this is the close price, TCS's close price from about 13 years, how the TCS close price has behaved. In fact, if you just plot log of TCS close price, you will see almost it has increased in a straight line. The log price has increased in a straight line. If a log of a value is increasing in a straight line, so it means basically the price is increasing exponentially. There is a compounding effect is happening in this TCS TCS price. Now, in my experience, stock market data is something is almost doesn't, you don't have any predictive ability. You can try any data set, any model, deep learning neural network or anything, and your predictive power will be as good as flipping a coin. Okay. Why? Because can anybody tell me why you cannot predict? So when in one hand, I have this kind of data set, toy data set, which I can predict almost with 90%, 99% accuracy, right? And on the other hand, here is this kind of times stock market data set. Nobody can predict. You can say that, okay, sir, I can see it is going up, it will go up. Yes, probably it will go up. But if you try to predict, if you try to say that, okay, tomorrow, what will be the price of the TCS? Most likely, with a very high, high probability, I can tell you that you will be wrong. It can go up, it can go down. You don't know what will happen tomorrow, whether the price will go up or go down. Okay, so if this is what, if you want to take a position based on a short-term position, then most likely you will be failing to, and it is a bit counterintuitive, because it looks like if you just stare at this data set, if you stare at this data time series data set, you will feel like it looks like it is going up and it will keep going up, right? But in the stock market data, data is extremely decisive. The data, it can deceive you completely, and it does not have any predictive ability. If you want to predict 1 day ahead or 2 day ahead, you can't predict much. One way to feel that why I can't predict much is if you take the first difference of the value. Okay, so I will take let's take the air passenger data and plot it. Okay, so this is my air passenger data. Okay, if you take the log of air passenger data, you can see that it is sort of increasing in a straight line, where your band is also almost fixed, and you can pretty much predict the whole thing. Now what I'm going to do, I'm going to take the consecutive difference of the air passenger data. So basically what I'm trying to do, I'm going to plot, I'm trying to plot log of air passenger data on time point t minus log of air passenger data at t minus 1. So I can take the two values, take the log and take the consecutive difference, and I'm going to plot that. Say I call it delta t, the first difference. Basically dt is going to be the first difference, and I'm going to take that first difference dt equal to this as a difference. Now I plot that, and I'm going to plot this dt. If I plot this dt, and now if you do that, if you look at carefully, your dt has a particular behavior, and you can pretty much predict that behavior. That if I just do a AB line at 0, okay, and let me just increase it in the size. Now take any year, okay, say 1952 to 1953. It always follow a particular pattern, and this pattern can be modeled essentially. Okay, if you can model the first difference, you can model basically model the entire function. So that is the idea, that even the first difference has a particular sinusoidal behavior, which, you can clearly say that there will be, after 3 peak on the positive side, then there will be a drop on the negative side, then again there will be 3 positive peak, then there will be a drop, then again there will be 3 positive peak, and then there will be a drop. So this you can model there is a very strong signal. You can learn this very quickly. Now you go to the TCS dataset and calculate the DT. DT is basically and plot DT. Sorry, this is, I have to do the difference. I have to do. So pretty much you can't explain anything, but there are too many data. So let me just plot the first 50 data points. Okay. If you look the first 50 data points, you can pretty much say that there is no repetitive behavior. In one day, it can be up, another day it can be down. You can, and if you increase it to say 100, there is no particular behavior it will follow. Okay, so these are the indications that, probably we would like to learn in the time series data sets. Now, the last part that I want to show you. Anybody have any question so far?
So here the problem is with the time series thing, or particularly with the stock market data?
No, it is particularly with the stock market data. So I'm just giving you an example where the time series is data is completely not predictable. Means you can try any complicated model. Going forward, when you will take time series analysis course in your third semester, ARMA model, ARIMA model, then in your deep learning network, you will learn Prophet model from Facebook and all these things, TensorFlow, whatever, RNN, recurring neural network, LSTM model. You take any of these models, apply it on a stock market data, you will not be able to predict. And you say, suppose if you want to predict whether the stock market will go up or down, if this is your problem definition, because if you decide tomorrow it will go up, I will buy today and sell at the end of the day. If that is the strategy that you are taking, then, and if your model predict it is going down, then tomorrow I will first sell and then at the end of the day I will buy it back. If that is the strategy, most likely your prediction on paper, like train test, your prediction will not cross more than 54%, 55% or 56%. And when you will actually apply it, it will, your performance not necessarily reach up to there 54, 55%. It will come down to 50, 52%. Basically, that means the model's predictive ability is as good as flipping a coin. Now, why is this that? This is particular to the stock market. It has nothing to do with the time series model or time series technique. Okay. So what it tells us that this time series behavior is going to be a very domain specific. And you have to understand a lot of time, you have to put a lot of effort understanding the domain. Okay, if you just learn, okay, I have learned how to do all this prediction and I'm going to, that is the mistake I have seen many people think they can do that. Okay, I have learned this data science technique, machine learning technique, I'm going to apply it in the stock market, I'm going to crack the code and I'll make a lot of money. Most likely you're going to lose money. Because, and why it is so, just think about it. If you can crack the code, there is enough smart enough people in the world who can crack the code as well. You are not the only genius in the world. There are a lot of other geniuses also there. If everybody is trying to crack the code and everybody is taking a position, okay, and so naturally, if you are going to take a up position, long position, or if you think the market is going to go up, so naturally there will be some smart people. If they know that you are going to, buy, they will sell at a higher price. They will say that, okay, I'm going to sell at a higher price because there will be a demand. They have predicted your position. So then there will be your prediction and the other people prediction will cancel each other, and eventually, and what will happen? Okay, suppose, let us take another position. Let us suppose you able to predict, your model really do have a predictive ability. So what we will do, you will start making some money. You will start buying. And some people will figure out that, okay, there is a guy who is always buying, and whenever he buys, after a while market will go up and then he sells. So 4, 5, 6 people will start mimicking you, and then there will be a buying pressure. And eventually some people figure out that, okay, here is a group, they always buy. When they buy, they push the market up, and then there will be some seller who will take a anti position. And in that way, basically your model will work for a while, and then eventually people will learn your strategy. And whenever you will take a strategy, there will be another algorithm who will basically try to kill you by selling the market. So in a sense, and that is the reason there is something called efficient market hypothesis in quantitative finance. And that says that nobody can actually predict the market if the information is correctly available. Anyway, I don't want to deviate from there. So this is a very specific to stock market. Okay. Okay. Any other question? All right. So let me just go and show you another example. So I have just cleaned my environment. Here is a dataset from apicovidindia.org. In this dataset was updating daily until 31st October of 2021. And then now they have stopped updating the data. So you can
Sir, just one more question.
Yeah.
Like as you said, the prediction capability in stock market data is very low. So then what is this should be the fundamental point while dealing with this data stock market. So what is the research going on? What is a lot of data science is applied in finance domain in stock market data. So what is the purpose of that if the prediction capability is very low?
So answer is very long. So, but I will not be able to give you, explain you everything in this short time. But people think that they will, couple of things. People think that they will be able to crack the code and they will be able to make money. So there is a thing that have people figured out. So the data that I just showed you, it's a daily level data. In the daily level data, you don't have any predictive power. At a minute level data, second level data, you do have some predictive power, and that is where the algorithmic trading comes in. So basically, you develop algorithms and you put it into the you put that algorithm in the NAC server in the co-location. There is something called co-location. You can hire in NAC servers. You can actually put hire a stack. In that stack, you can put your algorithm, and then your algorithm will take a position for you in the market. There people do make money. I'm not sure how much or how big, but my exposition, in my stand, it will not be like, you will become millionaire in overnight. No, I don't think people will be able to make money in that way, but you can make money. It's like more like a mark. So that's called algorithmic trading. But in terms of, so just like day trader, what used to be called day trader, I mean, now there are some who take a position on a day and study and do the technical analysis and all these things. Those technical analysis does not have any predictive power to predict the market and make money. We have done a lot of simulation study, uh, and our experience and our study shows that technical analysis at a daily level data does not work. But there are certain things that do work, and that is beyond of this course. Okay.
Okay.
Yeah. So you can see that the last data that has come on 31st October 2021. After that, this site has stopped working because it was working. There was a bunch of volunteers who were basically maintaining this site. After 31st October, they didn't had enough fund to carry on, so they stopped working. But we have, I think we can still use this data set to so do some analysis. I understand. So here I'm taking the data. So this data one is basically I'm going to pick basically India level data from 14th March 2020, and it has every day it has three values: confirmed value, recovered value, and deceased. Okay, and it India level data. So I'm going to plot the India level data. Here is I have given a small loop. I will share this data and this code with you after the class. Okay, Shromona is saying there is an alternative to the site now. Okay, can you please, Shromona, can you please share that site with me?
Yes, sir. Yes, sir. So it has been done by IIT, so it's just the same as that site only. I'm sharing the link here.
Okay, thank you. So let me just explain you this code. So this is the one, and then I'm going to use a ggplot. Okay. And this is the ggplot. All right. So this is how the times is. Probably most of you have seen this graph in many. Okay. So this is the, this is the same website. Probably the server is being adopted to somewhere else. Okay, good. That's okay. Who is maintaining this site, Sumana? Do you know?
So IIT, I don't remember which IIT, but someone from IIT. I can see and tell.
Okay, all right.
Is this in COVID.19 in COVID-19.org?
No, that is okay. But which group I was thinking? Anyway, fine.
IIT Madras
IT
and ISI and IISc.
Okay,
Yeah,
okay,
that's
all
what
right.
the site is saying.
Okay. That's good
Yeah.
to know. That's good to know. All right, that's very good news for us then. All right. So this is so now I have just saved this thing, and now there is what I have done. What I have also taken this library called gganimate. Okay, and if you just do, so you have done this plot. Okay, this is the plot, and then all you do add another layer called transition level by depth. And then what will happen? It will create a animation of the plot. So you can see that it's create a nice animation of the plot. Okay. And it will repeat. So let me just clear this thing out. Now, instead, you can, if you want to do a show the points, you can do the show the points. So I think it will show a point at the beginning. Yeah. So you can see there is a point at the beginning. It will do the points. All right. And this one, I think. Yeah, this is just another way of solving the same thing, but every points will be marked here. Okay. Now, if you want to save your animation, just say any underscore save, and you have to save it as a GIF file, GIF. You have to save it as a GIF file, and it will save. And if you give get working directory, so it will give you the path at where the file is being saved. If you just say get working directory, it will be go and save the file in the working directory. Okay. Now, if you have, say, several data sets, several time series, what I am going to do here, I'm going to do the same plot for TN, Tamil Nadu, KL, Kerala, K, Karnataka, and AP, Andhra Pradesh, 4 big states of South India. So I'll just take that, and now the data set is of data 1. Oh, sorry about that. Yeah. Then I have to do a little bit of manipulation. So and then if you run this, and so this is the actual original plot. So the green one is Kerala, and this purple, yellow, and the blue is AP, Andhra Pradesh, Karnataka, and yellow is Tamil Nadu. They kind of behaved similar to rest of the India as well. Kerala always behaved a very different. So their first peak was very different at a time where, and then they always stayed at a very high level, then second peak, and then they observed a third peak as well. So I think, so the disease progression in Kerala is actually very different from the rest of the country. And still, I don't know what are the reasons that resulted this behavior. But now if you just run this thing, it will basically show you how the three things have behaved. So it will take a little bit more time because it's processing 3 time series. So more time series will take a little bit more time. So you can see the 3 time series is going with. Okay. All right. Let me just clean this. And you can save it as a anim save. And as I said, you have to save it as a GIF file. All right. Now, if you actually go to the my teaching and then visualization course, there was a GIF file. Let me just okay, here is the GIF file. Okay, so you can see all the progress here. So some reason it's typically if you open the GIF file, it shows you. Yeah. Okay, so this is how. So you can find the GIF file here. I think I have done something else. Okay, this is another GIF file that I have created. So this was against GDP per capita and life expectancy of different countries. So big two bubbles are stands for China and India, and rest of the countries are basically all other big countries like US and UK and stuff like that. So, all right. So I think I will stop here for today. It is 10 minutes after the class. So